Alright, so fresh off the heels of the Cortec in the previous video that is unfixable until I can find a flyback, we have a box here with 3 chassis in it, and these all belong to the same person that had the Cortec. So let's take this apart here and open it up and see what lies inside. Alright, we have, first one here appears to be, what do we have here? K7000A. It is in fact a 7000A, the Zenith model. No neck board. Can't test. Well, I don't know what I'm going to do about that. Missing L1. Do you have a neck board you can sell me? Or you can keep this for parts and sell me a replacement. Oh, okay, well, we'll see. I have a neck board, but it's missing a bunch of parts. And I think the only parts it's missing are it's missing all of the drive pots, which I have drive pots. And it's missing C204, which that's no big deal because I've got a capacitor we can put in there from previous. So I would need, it's got all of the transistors. I would need to solder what looks like this is for a small neck tube. I need to find out from the owner of this if he has a tube, a 7-pin small neck tube, 1, 2, 3, 4, 5, 6, 7, yeah. I need to find out if he has a tube that he can use this on. Because I think all of the K7000As have the 9-pin large neck tubes. So let me find out. So I'll have to set that one aside and work on that one kind of last. But then we have here a K7400. What does this say? Recapped, new HOT, new flyback. I did the work. Does not power. I hear a ticking noise. Well, that usually means HOT is blown. So K7400. And what's the last one here? K7400. Powered up, very blurry image. Cap blew up as I adjusted focus on flyback. L1 broken. Well, that's linearity coil. Okay. No parts in here, so let's set this aside. And I guess we can start with this one because there's no real reason to start with any of the other ones. So there's no logical reason to pick any of those over this one. So we'll begin with this one. I need to find out from this guy if he wants me to try and get this going because that's the only spare neck board that I have. I can make it work if I can find the parts, which I'm pretty sure I have everything. So we'll see about that in another video. But for this one, we'll set this 7400 aside. Okay, and we'll begin with this one. All right. Okay, it's packaged the way I like to see. The neck board has been somewhat wrapped up, separate from the main chassis. I like that. The coil itself is not broken. It's just the magnet is loose, and nothing a little super glue won't take care of. But for now, I mean, you can just leave it sit like that. I'll glue it in place momentarily. Let's see. This said cap blew up. Well, let's look and see if we can figure out which cap that was. But first, let's look at the neck board here. Seems to be complete. Pots are in good shape. Is this a low hour one? Or is this a high hour one? This is a low hour one. There's hardly any burn on this at all. That's very nice shape. Yep, And we do have some lifted pads, but that's because these get moved around and they lift the pads. But not too bad. Nothing a little reflow and a little bit of super glue can't fix. This one here doesn't have lifted pads at all. So we can actually kind of set these in place the way they should be. Somewhat just like that. Oh, let's zoom out a bit, sorry. Somewhat just like that. And that should work out just fine. A little reflow when I do the cap kit, and we'll call that nice and good. Okay. So let's go ahead and remove our neck board. Jeez. Oh, I broke that. Good thing I have spares. I don't understand why these are so tough to get off sometimes. That's my fault. But I could probably super glue that back in place. I may just do that instead, because I have another cable. You know, this isn't mine, so I like to replace it with something that's not broken. But I may be able to just glue this back in place and be fine. I'll decide. So, well, sorry about that. That kind of stuff happens. Let's disconnect this and open up this and take this off. All right, neck board is in good shape. We'll set that aside. Remote board, let's go ahead and disconnect that. See, that came off a lot easier. Remote board is the correct one for the K7400. It all seems okay. Cable's in good shape, so we can set that aside. Now let's see if we can figure out which cap exploded. I don't... Oh! Right there. Right here. Yeah. Kaboom! Yep, why that would happen, I can't say, but we will find out. We will do our testing and we will get this solved and we'll get this up and running. Let's go ahead and zoom back out. Immediately, it's not in backwards, and it is the correct rating, 350 volt 2.2. That goes in that spot. So, I guess we can just start doing our testing. Let's take a look here and verify that everything is intact, nothing is missing. Let's get rid of this, push down, lift up, and it slides right off. Okay. Yeah, I don't see any missing components right out of the gate, so that bodes well. Let's look at the back side. Wow, this looks factory fresh. This doesn't look like anybody has done anything to this. It's always nice when you get one that hasn't been, you know, messed with and things like that. So it seems okay here. I don't see anything that jumps out at me. We've got cracked, very common cracked joints on the power connector. It's kind of hard to see, but this one here is not any good. You can see around there it is pretty much cracked right there. It's cracked. So it needs the usual reflow, but no big deal. Some stuff I have to hit before we even turn it on. So that's one of the things we have to hit before we even turn it on. So I guess we'll go ahead and just do our testing here. And we're not going to be able to do anything until we get this cap out of here. Well, I need to wait for my iron to heat up. What I'll do is we'll do our testing. If everything tests good and nothing tests bad, I'm going to change out just this single cap and then fire it up and see what happens, because it's quite possible that this cap simply just failed. It doesn't necessarily... A blown cap isn't necessarily indicative of something else wrong. You know, especially if Wells Gardner used really, really cheap caps on these to cut cost. So, yeah, it's very possible that this just simply failed for no reason other than just failing. But I could be wrong. So we'll do all of our testing, see if everything works great and nothing is out of the ordinary that would say, hey, it's not going to work because of this. We need to fix that first. I'll just change this cap out and we'll fire it up and see if it blows again. Then we know there's obviously a problem. But yeah, so let's go ahead and start our testing here. We'll begin with R104 like always. 10K to 13K is normal range. And we have, well, 9.8, good enough. Then we have our voltage regulator, this guy right there. We should have, let's see, I think this one's 1.0, okay, sorry, 1.0, and then this should be our voltage drop one over here. There we go. So HOT, I'm sorry, voltage regulator checks good. Man, I just recently I'm having all these problems with my brain, doesn't work so well anymore. Yeah, voltage regulator 1.0 and 0.5 voltage drop. Voltage regulator is good. So let's test our switch mode power supply chip. Like always, we want pin 3. I go 1, 2, 3, 4, 5, 6, 7, 8. Pin 3 to 4 should be, let's see, voltage drop. Yep. 2 to 1 should be voltage drop. Yeah, it's there, but it reads, that's 0.5 and 0.6. Usually I like to see in both the same 0.6 and 0.6, but we'll consider that okay for now. Let's see, 1, 4, 5, 6, 7 to 8, I think should be 1.5. Yep, and 6 to 5 should be 1.7, 1.8, close enough. So that seems to be okay. Zoom back out. We can test C121 because with C121 can cause a lot of problems over here in the horizontal circuit, and this cap could have been a casualty of that. So let's make sure C121 is good. And that is this right here. Now we're only checking to make sure it's not shorted. So if we just go to our continuity mode and touch this to here, it is not shorted. So we don't have to worry about C121. We can test our, well, I guess we've got that. We can test our C121 is good. We can test HOT. HOT, we'll go back to diode mode and we go here to here. 0.5 and 0.5. HOT is good. We can test K703, which is this guy here. Focus, you stupid camera. This guy, focus. Thank you, okay. This guy right here on the heatsink. And it should be from the center pin negative to the outside should be 1.0 on diode mode. 0.9, close enough. And the other side should be our voltage drop. There we go, 0.6, so K703 checks good. And our video header pins are good for solder, just checking those out real quick. Alright, well, I don't see any reason why it wouldn't power on, which we already know it powers on, it just blew the cap. I just wanted to make sure. So let's test our R811 to make sure we don't have any color problems. That's going to be this guy right here. This little resistor right here is R811. Again, if it's bad or out of spec, you won't have any color. You'll have black and white image. It's this resistor right there. Should be between 50 and 100 k ohms. So if we go here to here, we've got, yeah, well, 50 k ohm. Close enough. That's good. Let's test R303 to make sure we don't have horizontal, vertical collapse. My mistake. And vertical collapse is common on these. So R303 should be 1.2 ohms. That's exactly perfect. D302, of course, should be voltage drop right next to it. That is good. You even see what I'm doing? You can't even see what I'm doing. Sorry about that. This resistor here is R303, and this diode under here, underneath it, is D302. So we can test that. That's good. And then we go back to R303, and that should be 1.2. Come on. There we go, 1.1. So that's good, indicative of good voltage regulator, or vertical operation. I believe that this resistor here should be 470 ohms. Which one of these is 470? Am I wrong? 4.3, that's good. Was it this one? I could have swore, I'm probably wrong. You know, the 74, 75, 2000, 5000, there's so many variables that I get confused sometimes. But we're just checking to make sure that we're not out of spec, and I'm pretty sure that's a good resistor. 67, I think, is pretty good. So we're not going to worry too much about that. And then this one is 270 something, 200 something. Yeah, that's good. So let's check our D603. It gets confusing sometimes, you can understand. D603 should read this way. and it should not read the other way, or we have a shorted vertical IC. It does not. So all signs point to having no problems with this upon boot up. So let's go ahead and put it back together. Change this one cap. I'm not going to do the light bulb test on this because the note here says it powers up. It powers up. We know it works. I just tested it, so I'm not going to do the light bulb test. I usually only do those on ones that I don't, if this specifically says powered up, I know it works. So if I don't get a note that says working except for blah, 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 I'll just do the light bulb test on those. But so let's change out this one cap here. It's very possible it just simply went bad. And it really exploded with a good fashion there. All right, let's wick away. I gotta turn my fan on here. Let's wick away. Where did you go, my lovely? Where did you go? Okay, now we need to see if we can find ourselves a 350 volt 2.2. So I'm gonna grab my bag of capacitors here and see if we can find a 350 volt 2.2. Well, there's our 250 volt 4.7 that we're going to put in the neck board for that 7000A if we come across that. So I'm going to save that and replace that one with this one. So, okay, 350 volt 3.3. There's 250 volt 2.2. I'm gonna, just to save time, I'm going to cut away here and find it and come back. Alright, so I took a deep dive into my stash and I could not find a brand new 350 volt 2.2. The 7400 and 7500 are the only two chassis that have this cap in this location. The U2000 and 5000 don't even have this location. There's no cap there. There's not a spot for it. So I only have the option to rob this from a from a K7400 that I just had sitting here as, a donor chassis. So we are going to put this one in and hope it doesn't blow up. I mean, it should be good. So we'll put this in here just for testing, and if it works and I can get everything dialed in here, we're going to see if I can't. I don't have a full cap kit for a 7400 or a 7500. They're the same cap kit. I don't have one in stock. So I do have all of the correct caps, though. I have plenty of spare caps floating around that I could use to do this cap kit, but it turns out I have all of them except for the 350 volt 2.2. The one cap that blew up, I don't seem to have one. But we'll solder this one in here and just see if it works. And if it blows up, I'll have to order some caps and move on to a different chassis and continue this one later. Alright, and that is successfully soldered in. Let's make sure it's in correctly. It is installed correctly. So, yep. Okay, well, let's put it back together. Alright, and I don't have access to my spare cable at the moment. So we're just going to put this one back in here the way that it was. Goes like this. And then we'll put this guy right here. Oh, come on. This is all face that way, so let's face you that way. And let's put you in here. Alright, and then we'll put this back on. And then we'll put this back on. Alright, mission accomplished there. And you never know. But that's not what we're about. We're about fixing things properly. So I'll get that done at some point. But in the meantime, put this back in here. And this back on here. Okay. So that should be everything, and I believe we are ready to test this. Let me actually, before I forget, let's go ahead and put a little glue on this linearity coil here. That should work, and we'll just hold that in place for a few minutes. I'm going to hold it here for about a minute, and I'll just cut away and come right back. Okay, so now we have a linearity coil that's nice and secure. I'm moving it around, it's not loose, so that should be, oh, yeah, that should be good for now. So let's take our subcontrast pot. The subcontrast pot here is only on the 74-7500. I had a video recently where I talked about how it was only on the 7400, but I was mistaken. So we'll take this, wipe it a few times, and just set it back to center. So that's good. And then we'll take all of our color pots and move them around. And I like to set them back to center, but usually that seems to be overdriven on this stuff. So I'm actually going to start putting them about maybe, I'd say 30%. I think I'm going to switch from putting them halfway to the 30% mark, because in my experience, having them halfway seems to cause way too much color overdrive. So we're going to start putting them about 30%. That's all the way down, all the way up. Let's do about 30%. And of course the drive pots will leave it halfway. Okay, I do believe that we are ready for testing, so let's grab a picture tube and hook it up and see if this cap stays intact, and if so, how long. We'll let it run for a while and see what happens. If it's all good and I don't see anything happening within half an hour or so, I'll consider it okay, and then we'll see if we can't piece together a cap kit, do a reflow, another inspection, get some neckboard work done, and make a nice, quick, easy repair of this. So let's get a tube and see what we get. Alright, let's see if any magic smoke comes out. We have everything hooked up, anode, neck, yoke, ground, video, power, remote board, and we have our meter hooked up, ready to read our B+. Of course, we're expecting to see 117, but anywhere between 116 and 118 should be fine. And the connection point to test it at on the 7400 is right there. It's test point 202. You can kind of see where it says test point 202 B+. There's a little test point right there. That's where you test that. And then if it works, we're also going to test our shutdown pot. If you look right here, there's a little test point right there. Oh, come on. Right there is test point 201. You can kind of see it there, test point 201. And that's where you test your shutdown pot, that little pot right there. You want it to read 0.1 volts DC. I have not been testing this in the past, and I even made a comment about how it should read about 4.5K in the middle range. But I'm a little bit incorrect on that, because if you look at this one, it's pretty much almost all the way over to the right. It's hard to see, sorry about that. It's almost completely maxed out, all the way to the right, clockwise. So we want to measure that and make sure it reads 0.1 volts on that test point right there. And if it is, then our shutdown pot is set correctly. If it's, 0.68 or 0.51, no, I'm sorry, 0.050, 0.061, whatever, it's too low. The voltage at that test point should be 0.1 volts DC, and that is the optimal setting for the shutdown pot. So first let's turn it on, make sure we don't have any magic smoke coming out of the capacitor there. If that seems stable and works, we'll make sure our B+ is good. Then we'll move on over to this test point to make sure we have our 0.1 volts. Now I also want to say that I have this on a dedicated, if you can read here, right there, model number 25-inch K7400. Now, I've been using this to test K7000s, so I have a different bottom frame piece on here, but this will sit in here just fine for testing. So nothing to it but to do it. Let's turn it on and cross our fingers and see if anything happens. Make sure we have good B+. 1, 2, 3. 119. That's not bad. And so far, so good. It's kind of bright there. I don't see it bubbling. I don't hear any noises. It's too early to tell, but I think that cap that blew up was just simply bad. We don't have an image because I have the contrast and brightness turned completely down at the moment. And we're at 119, which is forgivable. Can I even adjust it? I didn't even look to see if I could adjust it. And the pot's sealed shut, so there's nothing I'm going to be able to do about that. It'll run on 119 just fine. And it seems okay, so let's go ahead and turn up our flyback until we get an image. Let's see here. That's focus, you dummy. Hey, there we go. We got raster lines back down till they just go away. And we can actually adjust our focus right there. Oh, that's beautiful there. Okay, now contrast and brightness. Let's go ahead and set the camera up here like this so we can get a better shot here. Contrast, brightness, brightness. I have no brightness control. I have no brightness control. That's very interesting. I have no brightness control. Huh. First time I've come across that. And we're also way too blue, but regardless of that, yeah, we're down to 118.4. So, yeah, that's fine. I'm happy with that. That's fine. Anywhere between 116 and 118. 118.6, that's fine. Again, it should be 117, but we'll call that okay. Now let's go ahead and disconnect this connector here, and we'll plug it onto our test point 201, which is this guy right here. Focus up, camera. Come on. There we go. So let's put this one on there. There it is. And we are 0.01. That's way, it should be 0.1. Man, that is way off, completely way off. 0.1 is what we should have. That is wrong. So we're going to have to see if we can adjust that. I don't think I'll be able to because it's glued in place. I'll try, but usually you just end up breaking the pot. It's a 5K? 10K, I think it's 10K. I think it's a 10K pot. In which case I should be able to find a 10K pot there. This camera is a piece of junk. Sorry about the constant loss of focus. But that's nowhere near correct. So I'm surprised it's even operating with that. But I don't understand why I don't have any brightness control. It could be a cold solder joint or it could be a bad pot. I can't say, but I'm turning the brightness pot and nothing happens. Nothing. So I'll try and figure. Whoa, we had a flash there. Had a flash there and had raster lines. Well, so far so good on that cap. I think we're going to be okay. But I think what we'll do here is, now that we know this is operational, I'm going to try and see if I can adjust the pots to where they need to be. And if we get all that situated, then I'll do the full cap kit, full reflow, and see if that fixes our brightness problem. If not, I'll see if I can figure out the circuitry on that, and that's a secondary problem. But at least it's operating now, and we don't have a pot that's exploding. It looks good. Is it hot? No, it's ice cold. So I think we're okay. I think that pot's just simply failed. I keep saying pot. I'm sorry. The cap. The cap is ice cold. It's not hot. It's not bubbling inside. So I think we just simply had a bad cap, had failed over time, because they are crappy caps from the factory. But yeah, operational. So let's go ahead and see if I can get this pot adjusted, broken free and adjusted. I'm not going to worry about B+. It's fine. But I want to get that adjusted correctly to our 0.1. We're way off. I'm not surprised we're way off because that pot is almost like 90 degrees to its maximum right-hand clockwise setting. It should be roughly either in the middle or slightly to the left of that. So if I'm not mistaken.
So let's go ahead and get that fixed and figured out, and then we'll worry about trying to get this brightness issue figured out and cap kit and reflow. So I'm going to cut away, come back, see if I can get that broken loose and get this adjusted to 0.1. That's hard to remember, 0.1. So stand by.
Well, I got this all fixed, and this turned out to be quite the adventure. The no brightness control ended up being caused by an open R305. This guy right here. This resistor is baked, and it is completely open. And it goes right here. I was able to source one off of my parts 7400. And it's this guy right here. Come on. This guy right here. This is R305. And the cap that was blown was C808. And they share a pathway right over to pin 9 of the flyback. So, based off the fact that R305 was open, R305 being open allowed unfiltered voltage, so to speak, to get to C808 and cause it to explode. So it was kind of a chain reaction event. And I also talked about how test point 201 you should read 0.1. And we saw how I was reading, what, 0.0019 or something. I was not reading properly. I was able to successfully break off the glue from the pot and adjust it. And when I did that, I adjusted it up and down, and that made no change to the test point. I was getting still 0.0017 to 0.0019 no matter what I did to the pot. And that was wrong. I knew something was very wrong with that. And this test point actually is part of the flyback circuit as well. So if you look at the schematic, this is part of the flyback circuit, and R305 is part of the flyback circuit and runs right to C808. It's all part of the flyback coming off of pin 9. So I put a brand new flyback in here, as you can see. I'll show you the old one here. The old one is right here. There's the old one. So it looked good, but the flyback was bad. The flyback was bad, and it took out R305, which in turn took out C808, and which in turn was causing us to not be able to read proper voltage on our test point 201. So after replacing the flyback, I gave this a test, and not only did I have my proper brightness control. You don't have much range because these don't really have much range traditionally anyway, but I had my brightness control was restored. That was due to R305 being bad. And of course, with R305 being good now, C808 should be reliably good as well. And not only that, I also had proper voltage at my test point. Actually, it was 0.5, and I had to turn it clockwise a little bit to get to 0.1. So it's actually 0.112, close enough. But I had to adjust the pot slightly because it was actually at 0.5. So yeah, after changing the flyback was the cause of our entire problem. If we look at the schematic here, let me bring it up real quick. One moment, I took a screen capture of it just so we could look at it. Let's go back to here. Okay, so if we look at our schematic here, this is our flyback transformer. You can see screen, focus. This is our flyback transformer, and coming out of pin 9 right here, you can see it comes down here and goes through R305, and it goes through C303 right down here to C808. This is the capacitor that exploded. This is the resistor that burned up, and it comes right from pin 9 off the flyback. So right there I knew that the flyback was probably the cause of our problem. So I put a new one in, did a full cap kit, full reflow, replaced R305, and tested it, and it's now working perfectly. So this whole issue that we were facing there was all due to a bad flyback. So let's get it on the tube and we'll do final testing, and we'll see if I can show it off here in proper operation. So let's check it out. Actually, first, something else I wanted to show here is all these test points. If we look here, let me zoom in a bit actually. You can see here these test points. If we look here, test point 201, it should be, that's the 0.10. So if you look here on the actual manual, it references where these test points, what they should read. For instance, test point 202 is our B+, that's the 117.2. So as long as you get to 117, your B+ should be good. And then the test point 201, which is the shutdown pot test point, there's our 0.1. And like I say, I was only ever able to get 0.0017 or 0.0019 no matter what I did. And that was because of the faulty flyback. Now I can get it to 0, I think it's right now it's 0.112. So that was the cause of that problem. So these are some test points for reference here if you ever need to do some adjustments. And test point 203 is right here. And even though it says video B+, it's actually brightness, your brightness. You should have, this test point here is not the B+. B+ is this test point right here. Right here. Test point 202 is your actual B+. Why they labeled this one B+, I don't know, but this is actually for the brightness circuit. You can follow this, and it goes right over here to the VB, video brightness. So that's what this actually does. It should be 152 volts. And with this, with the old flyback in here, I was getting 145. With the new flyback, I get 151. So that flyback was bad in more ways than one. So now, okay, I wanted to point that out. So let's get it on a tube and do some final testing here and show it in operation. And we'll show the test point here working and the brightness control. And yep, that should be it. Solve the problem. The schematic actually shows this cap as being a 200 volt 2.2. The cap that was in here from the factory is a 350 volt. If we look here, yeah, 350 volt, 350 volt 2.2. And I looked high and low and couldn't find one, so I had to rob one from another one, or I had to rob one from the donor chassis. But if we look at the schematic, let me bring it up here again. If we look at the schematic, you can see that it's actually 200 volt 2.2. So I may put another one in here, but let's go ahead and test it the way that it is, and I'll show you that it's working, and probably off camera I'll just change it back out to a 200 volt 2.2 because that's what the schematic shows should be in there, and I got plenty of those, so I wanted to point that out as well. All right, so now, third time's a charm. Let's get it hooked up now and see what it does, so stand by. Okay, all hooked up. It's actually been running for about 10 minutes. I wanted to give it some time to heat up and operate so it can give you a general idea of what the image looks like. Now this tube is a bit tired. It spent a lot of years running in a 25th anniversary, or 20th anniversary Miss Pac-Man Galaga. So it's got some pretty good screen burn, and it's a tired old tube, and the blue is much more active than the red and the green. I tried to rejuvenate the red and the green, and it works, but the emission for red and green is about, I don't know, 25% less than blue, so it's a little bit too blue. And I have blue turned down as far as it can go, so the image is a bit too blue. But that's actually, it's a picture tube problem, not a chassis problem, so just kind of ignore that. But it'll look good when you see it. So after getting all the work done, you can see here I have all the old caps, the old glue from the shutdown pot, and the bad R305. It's completely and totally open. The bad flyback is there. So after changing the flyback, all the caps, the R305, we have brightness control, contrast control, all the controls work. I have the image perfectly square in the screen. It's adjusted properly. Not only that, we can go to our test point 201 now, and I mentioned before how it's supposed to be 0.1, and if we look at the meter, 0.1. And it fluctuates a bit depending on what's on the screen, but 0.1, that's perfect. Bada bing. And not only that, look at our B+ now. After doing the cap kit and getting the flyback replaced without changing anything on the B+ pot, I did not adjust it at all. It's glued in place thoroughly, so I can't mess with it. Oh, if we look at our B+, get on there, you rascal. If you look at our B+ now, 117. It'll go down to 117.5 there, 117.3. So yeah, without doing anything to the B+ pot, after replacing the flyback and doing the cap kit and all the reflow, the B+ is now perfect as well. So we're all good to go. Yeah, like I say, that circuitry that runs to this test point, that I could turn the pot, I was able to turn the pot up and down after getting the glue off of it.
I would turn it, you know, this way, and no matter what I did, the voltage would never change. So looking at the schematic, it's a very short jump from the circuit right through to the flyback. It actually goes through, well, let me rephrase. The circuitry for the test point for the shutdown voltage actually goes through to the flyback. That's how I discovered the flyback was actually the culprit for not being able to adjust the shutdown. And the cap here that exploded, along with R305, is part of the circuit for the brightness control. If you follow the circuit from the brightness input at the remote board connection, it goes through a diode, and it goes through that capacitor that exploded, and it goes through R305, it goes right to the flyback. The flyback's what supplies the brightness voltage. So we had the flyback was causing our inability to adjust brightness. Well, it wasn't directly. It caused the R305 to burn up, which was the cause of the no brightness control. It caused the R305 to blow up, and it blew up the cap. So if I'd have left this on for any length of period of time, I'm sure that cap would have exploded as well. So I was able to do a full cap kit except that one cap. I'll get with the owner of this to see if he's okay with that. But that all being said, so now after changing out all the caps, the flyback, the bad R305, and adjusting the shutdown pot to achieve, well, let's go back and just make sure it's still 0.1. There we go. Oh my lord, absolutely perfect! Ha! So, yeah, with all that being done, I am pleased to say that we are looking good. Like I say, it's a bit too blue, but that's the tube, not the chassis. Yeah, so this is outstanding. I gotta say, it wasn't too bad of a repair, but it was very interesting. I learned a lot on the circuitry and how this operates and everything for the shutdown circuit and all that stuff. So yeah, very interesting. I haven't come across one of these before that had no brightness control, and I've never seen that R305 burn up or that cap explode. I've never seen the flyback cause that before. So I learned something here, and I guess you guys have learned something. So now if you see, if I adjust my brightness, you can see, well, there's not much control here, but I now have, let's wait for a darker screen here. It's hard to see there. I can turn the brightness up and down now. These chassis never really had that big of a range of brightness control, but you can see that it does work. Up, down, up, down. So now I have brightness control. And yeah, they never really had a big history of having a lot of range of brightness control. But it's glorious now. A little bit too blue, but otherwise, yeah, it's perfect. Nice. Well, a little bit of gouging in the corner, but... So, that about wraps it up. We had a bad flyback that took out a resistor and was causing inability to adjust our shutdown pot, voltage I should say, on the meter. Look at that, back to 0.1. Outstanding. Yeah, and other stuff. So, I'm pleased to say this is now repaired, and I'll let it run for another hour or so, and stay tuned for the next two. I actually, that... where did it go? Here it is. Okay, so I mentioned that K7000A that this person had sent me. I had no neck board for it. I actually do have a neck board. This K7000 was part of a tube and setup that was in a fire. Now, this wasn't directly in the fire, but the heat and the smoke damaged it. You know, as you can see, it's very brown and baked. But in theory it should work, so I'm going to try and use this on that K7000A, which it should work. And yeah, I'll see if I can get this to work and get that K7000A going. So stay tuned for that. I'll probably do that in the next video, and it should provide some very interesting analysis and very interesting troubleshooting and trying to get it working, and we'll see how it turns out. But otherwise, yeah, thanks for watching. I know I learned something, hopefully you did. And like, share, and subscribe if you want. And stay tuned for the 7000A. We'll see how that goes. Much appreciated.